In California, roughly 20 oarfish washed ashore across 123 years. Then, 3 appeared in 90 days. In Japanese folklore, oarfish are called Ryugu no Sokai, messengers from the sea god's palace. The legend said when they rose, the earth would shake. Before the 2011 Tōhoku disaster, reports of oarfish along Japan's coast fueled the belief. Then the earthquake and tsunami killed nearly 20,000 people. Now, oarfish are showing up on coastlines around the world. The strandings are real, the Doomsday label is wrong, and the real reason is in plain sight, something nobody wants to admit. The California Cluster. August 10th, 2024. Kayakers and snorkelers off La Jolla Cove spot something silver hanging below them, 12 feet long, already dead. They haul it to shore. Scientists from Scripps and NOAA collect fresh samples. Late September, another one surfaces near Huntington Beach, too far gone to study. November 6th, a 9.5-foot oarfish washes ashore at Grandview Beach. 3 fish, 1 season. It has happened before. In October 2013, an 18-foot oarfish washed up on Catalina Island. 5 days later, a 14-footer appeared in Oceanside. Scientists who examined the Catalina fish found it riddled with tapeworm larvae. But even with the 2013 cluster, the average was roughly 1 oarfish every 6 years. 2024 delivered 3 in a single season. The La Jolla specimen went through a full necropsy, an animal autopsy, mapping its DNA, testing its body for microplastics, piecing together what it ate and where. They found it in good condition, yet the cause of death went unexplained. The biology of a ghost. The oarfish can reach around 26 feet. Unconfirmed reports put them at double that. The largest bony fish on Earth. No scales, just skin coated in guanine, a reflective compound that makes them shimmer. Every verified California specimen belongs to Russell's oarfish, and that includes the 2024 cluster, a species originally concentrated in the Western Pacific, now appearing repeatedly on the American coastline. No one fully understands why. Since the 1500s, sailors described ribbon-shaped creatures as long as their ships and drew them on maps as sea serpents. The oarfish is the most likely source. In 1996, U.S. Navy sailors posed with a 23-foot specimen found off San Diego. The oarfish has been labeled a fragile creature compared to other fish of its size. No swim bladder, the organ most fish use to stay at depth. Almost no muscle mass, ribbon-thin and soft, almost jelly-like. Its brain is roughly an inch long, smaller than its own eye. When it swims, it holds its body rigid and ripples a single red dorsal fin along its entire back. Sometimes it floats vertically, hanging motionless in the water column. Its mouth pushes outward to vacuum up krill. No teeth. In 2019, Japanese researchers hatched oarfish larvae in a lab for the first time, using eggs from 2 specimens caught off Okinawa. The larvae hung head down, mouths open, swimming with their front fins. Researchers offered food. The larvae had fully developed mouths, but never ate. They starved within 4 days. What does an animal this fragile hunt in near total darkness? And why would it amputate its own tail? Most fish navigate by smell. Dr. Tyson Roberts examined roughly 35 specimens before his death in 2025. The leading oarfish researcher had never located a nostril. No external opening. The scents appeared to be missing. Then he found them, at the front of the snout, opening inward, hidden inside the mouth. To catch scent trails at depth, the oarfish keeps its jaws partially open and pumps water through. It rotates its body, opening and closing the nostrils to test the scent from each side. That's how it finds the source. The vertical posture, the open mouth, the slow rotation divers often observed. The oarfish is hunting by smell, and what it follows is krill. It lives in the twilight zone, roughly 600 to 3,000 feet down. Cold, dim water. The twilight zone may contain more fish by weight than all other ocean zones combined. Most of it has never been studied. Every night, krill rise from this zone toward the surface to feed on plankton. It's part of the largest animal migration on the planet. The oarfish follows them upward. On most nights, it likely feeds and returns to depth, but with so little muscle, it has almost no ability to fight its way back down if something goes wrong. A current, an injury, a shift in water temperature. And then there's the tail. Oarfish amputate their own tails, a behavior called autotomy. Their organs are packed into the front quarter, so losing the back end damages nothing vital. They survive, shorter, lighter, and on purpose. Every Russell's oarfish specimen over 5 feet long has a shortened body. The bones in its spine break cleanly. The wound heals. The tail never regrows. Oarfish do have predators. They pick up parasitic worms from the krill they eat. Those worms have also been found in sperm whales and short-fin mako sharks, suggesting both species may feed on oarfish. But no shark attack on an oarfish has ever been documented. There's been a recorded instance of pilot whales attacking an oarfish, but they didn't eat it. The best theory for autonomy is that it reduces the energy cost of a body that long. A fish that sheds its own body to save fuel. A geologist in Italy found the only oarfish fossil on record, the rear section dating back roughly 3 million years. The break was clean, the same autotomy pattern locked in seafloor sediment. This behavior is older than the human species. Between 2008 and 2011, underwater robots in the Gulf of Mexico recorded 5 healthy oarfish at depths up to nearly 1,600 feet, making it the deepest verified sighting of the species. In every case, the fish barely reacted to the vehicles, consistent with an animal that has few natural predators. The California fish were dying on sand. Something had changed. But what? The real explanations. The canyons. Southern California's underwater terrain is steep. Submarine canyons, deep underwater valleys, cut close to shore and bring deep water unusually near the coastline. Off La Jolla, those canyons sit practically next to the beach. Scripps Canyon begins in water 40 feet deep and drops to nearly 1,000 feet just over a mile from shore. If a deep sea fish is already weakened or lost, it doesn't have far to travel before washing up. The ocean is layered. Warm water sits on cold water, and those layers move. When tides slam against these underwater cliffs, they can shove deep, cold water up and over the shelf. An oarfish caught in one of those pulses has no way to get back to depth. With barely any muscle to fight the current, it goes where the water takes it. This explains why Southern California sees oarfish more than other coastlines. It also explains why the same stretches of coastline keep producing strandings. La Jolla and Encinitas, because the canyons are right there. But the canyons have always been there. They don't explain 2024. Environmental stress. The deep ocean is warming in ways scientists are only beginning to measure. Researchers point to rising temperatures, shifting oxygen levels, and disruptions to the thermocline. The boundary between warm and cold water. Warmer water holds less dissolved oxygen, and oarfish depend on a narrow range of both. The hypothesis is that if the twilight zone's temperature or oxygen levels shift even slightly, the band of water where oarfish can survive gets narrower. Animals adapted to such specific conditions have nowhere to go, except up. And there is data behind it. In 2013, 2 oarfish washed up in California during the blob, a warm weather event that raised ocean temperatures by as much as 5 degrees Fahrenheit. During the strong 2015 El Nino, California strandings jumped to 5 in a single year. In 2024, the cluster overlapped with a red tide and Santa Ana winds, though no single cause has been confirmed. Which trigger matters most is still unclear, but the pattern runs in one direction. And the earthquake prediction? A 2019 study compared deep-sea fish sightings against earthquake records over 80 years. No link. The original Japanese earthquake myth is about a giant catfish called Namazu, said to be trapped underground by a god. When the god lets his guard down, the catfish thrashes and the earth shakes. That belief is over 600 years old. The oarfish connection is modern and has no basis. The strandings still have no complete answer, and oarfish have started showing up in places that have never documented one before. Was this still a local problem? Or was something deeper happening across the entire ocean? The global pattern. Sri Lanka's first documented oarfish was caught off the western coast in 2021, a Russell's oarfish, roughly 8.5 feet long. The identification was confirmed in 2025, a species previously recorded in the Pacific and Atlantic, now confirmed in the Indian Ocean. February 9, 2025, a live oarfish struggled in the shallows off Baja California Sur, Mexico, showing the same disoriented behavior, the same pull toward shore. Beachgoers captured it on video. It went viral. June 2025, an oarfish washed up on Tasmania's west coast. It was discovered on a remote beach near Strahan. 3 continents, 3 oceans. A 2020 study measured how fast livable temperature zones are moving through the ocean. Every species in the twilight zone survives in a narrow band of temperature. As the ocean warms, those bands shift. By the end of this century, they could move 4 to 11 times faster in the deep ocean than they do near the surface. That may explain why deep-sea creatures are increasingly showing up in the shallows, disoriented and dying. And oarfish are not the only deep-sea species washing ashore. Football fish, a type of deep-sea anglerfish that lives at depths of 2,000 feet or more, have started appearing on the same Southern California beaches. Only around 41 mature females have ever been recorded worldwide, and 3 of those washed ashore in California in 2021 alone. Lancet fish, another deepwater species, have turned up at La Jolla shores too. Species that were never meant to reach the beach are finding themselves there. If the large species are turning up dead, the small ones could be disappearing without a trace. The creatures in the twilight zone pull billions of tons of carbon out of the atmosphere every year. If that ecosystem is failing, the consequences reach far beyond the ocean. But there is one more explanation, and it has nothing to do with the ocean. The simplest explanation. Some clusters are real. Some are just more eyes on the water. Everyone has a phone. Kayakers carry cameras. There's more coastline under constant observation than at any point in human history. 100 years ago, if a fisherman saw a 12-foot silver ribbon wash ashore, maybe he told a story at a bar. Maybe not. Today, that same fish gets filmed, uploaded, and shared with millions before the tide goes out. The La Jolla oarfish was found by kayakers who recognized what they were looking at, and several had marine science backgrounds. A generation ago, that fish might have drifted out with the current and never been documented. The oarfish didn't change. Technology did. And as the world documents more of everything, rare sightings stop looking as rare. Better reporting alone does not explain a fish in good condition washing up dead, but it most likely explains why the numbers look like they're rising. The folklore called it a messenger from the sea god. The earthquake connection was never real. But the bodies keep washing ashore, and the complete picture of why these animals reach the surface at all still has missing pieces. What's changing down there that we'd never see until something washes ashore? Every oarfish that washes ashore is a piece of evidence from a part of the ocean we barely understand. We're just beginning to learn how to read them. What's your theory? Let me know in the comments. This is a whale that dives into the twilight zone deeper than 3,000 feet. Find out why the entire ocean goes silent when a sperm whale hunts. That video is on screen now. Subscribe to discover more mysteries below the blue. See you in the deep.